The concept of product engineering optimization, I will show you a demonstration by using this bracket. So this bracket I already create and capture the parameters that I allow the bracket to change, such as the bracket thickness, the rib thickness, the radius, and also the rib angle. So for this particular bracket, the actual application is that this bracket is going to be bolted to the wall, and then a load going to be applied on this area that's shown. So to test the strength integrity of this particular bracket, we already create a static analysis case. So we can focus on this area. So to replicate this bracket being bolted to the wall, I already put a restraint, which is a surface slider for the whole surface and also clamp for the two holes. And to replicate the load being applied to the bracket, I already applied a distributed force on the area that's shown. So the load that being applied is 500 Newton. Then after I run the simulation, I get a maximum translation displacement on this particular area, and then the value is 0.7 mm. Let's say my target value for this particular bracket is I only allow it to displace a maximum magnitude of 0.3. So the question is, what are the value for the parameters that I need to change in able to get that particular target? So this is the recognized parameters that I allow to change. But what are the value that I need to put here? Manual way previously that we conducted is that I need to do the modification manually, whereby I entered maybe bracket thickness of a certain value, rib thickness of certain value, radius, and also an angle. Then I simulate it in the analysis, and I need to do it back and forth. Change the design, simulate. Change the design, simulate. So by using this method of manual iteration, the optimization time is tedious and also long. The cycle of the optimization is long. And even though I will get a value, I cannot know for sure either that design is the optimized one. So here I'm going to demonstrate a concept of engineering optimizer, whereby I will use the system, which is the product engineering optimizer, and the system going to conduct the optimization for me. So this is the optimization window, and then the optimization type I can choose. Either I want to minimize certain value, I want to maximize certain value, or I want to achieve certain target. So for this case, I want to achieve certain target value. So what are the target value that I try to achieve here? I try to achieve a target value for this maximum displacement. The current displacement is 0.7, and maybe I want to achieve, okay, let's say I want to achieve 0.3, but I put a bit lesser value, because usually for optimization, sometimes we would not get that value per exact. So if I aim it a bit lower, maybe I can get the value. So if my target is 0.3, maybe I can put 0.29 as my target value. So as I put a target value, what are the parameters that I allow the system to vary or to change? Meaning that what are the parameters that the system can play around so that it can try to get this target value. So here, I recognize that these parameters stated over here are the parameters that I allow it to change, or I allow the system to play around to get this particular value. But as I allow it to change, I also need to put a certain constraint, because if I don't put any constraint, then the system will put any value. So usually for this particular product or for this particular design, mass is a role that I need to taking care of. So to control the mass, maybe my standard is that I have a certain bracket thickness maximum value and also certain rib thickness maximum value. So these are the two constraints that I need to control. So I put a new constraint over here. So the first constraint is the bracket thickness. So here I put less or equal to 6 mm. meaning that I allow the system to give any kind of value between 6 and below. So this is our first constraint. Then the second constraint is the rib thickness. So the rib thickness, I also, for example's sake, I'm choosing the same value, meaning for the rib thickness also the maximum value that you're allowed to go is 6 and below. So meaning by applying this, the bracket thickness and the rib thickness will change accordingly and will not exceed 6 mm, because that is the maximum value that I already put there. So next I will choose 2 minutes as my maximum time for the computation, and I can choose the run behavior. If I choose to without visualization update, it will be faster, but for the demonstration sake I will choose with visualization update, so that you can see how the parts being thickened and how the parts of the management displacement is being updated accordingly. So as I click run optimization, I need to specify certain Excel file. So what is this Excel file? So my optimization will conduct few iteration. So all the few iteration will be kept on here on the optimization result, meaning at the end of the day you can also choose a different value if you think that the optimized value that being suggested by the system is not the one that you like. Okay, so this one I click save, and as I click save, you can see that the optimization will be started. So like we observed previously, even though the system have a certain level of intelligence, you may need a certain experience in order to optimize it, meaning that it cannot just optimize any parameters. I need to recognize what are the parameters that play a role, or what are the parameters that you know by engineering experience that if I change these parameters I will have this kind of effect, and then I only don't know how much the value that I need to play around with. So you already recognize the parameters, you already put the constraint to make sure that it's following a certain standard. So you can see that how the part is being updated and how the maximum displacement is being updated. Sometimes higher, sometimes lower, because it will change the parameters and run the simulation concurrently. So if you want to have a more accurate result, you can put a longer period of elapsed time. So if I put 2 minutes, there's a possibility where after I achieve the result, it will not be the optimized result, but it may be close to the target value. So if you want to make sure that you have a much more accurate results, you can maybe put here maybe 5 minutes, and you can also put a number of updates is even more. So this is showing the concept of optimization being done automatically, and then while this optimization being performed by the system, the engineer or the user can focus his or her time doing something else. So you don't have to spend your time to do this repetitive work, whereby you can use the system to optimize it for you. So right now we can show that optimization is already being done, and using the number 28 iteration. Later we'll see on the Excel file. So I can change back to analysis to update all the sensor. So you can see right now I managed to get 0.29 of maximum displacement, and you can see there is a slight increase on the mass. You can also observe on the analysis itself. Okay, you can also see that there are certain thickness addition on the bracket thickness and also for the bracket. You can observe the value over here. So you can see right now the bracket thickness is 5.35, the thickness is 5.6, the radius is 7.5, and actually I'm using a higher degree, which is 49, maybe 50 degree. Okay. So for this case, I managed to successfully achieve the target value. So if I want to see the other iteration that's being done by the system, I can open the Excel file that I already saved here. So this is the different other iteration that is being conducted. So you can see in total it run 39 optimization. So meaning that 39 simulation and changes until it get the actual result. And then among these 39, it choose the number 28, which is achieved closer, which is 0.29, which is the target value that we intended to. So that is the concept of product engineering optimization.